Good morning, good evening and good night. Welcome to this lecture. This is the third lecture on electrochemistry. In the previous two lectures, we have discussed different aspects of this chapter. In the first lecture, we have discussed about the construction of the galvanic cell, and we understand how the chemical energy has been transformed into the electrical energy with the help of the redox reaction, which has been carried out in the two different half cells. In the one half cell, that is which called the anode, where the oxidation is taking place, and another half cell that is called the cathode, where the reduction is taking place. And in the second lecture, we have discussed about how do we be able to represent the electrochemical cell and how do we able to calculate the cell potential. And number third, we have discussed how we able to calculate the electrode potential with respect to the standard hydrogen electrode. Again, in this lecture, this is also a very important thing that we are going to discuss, that is the electrochemical series. This is K.K. Mukherjee in the Science with Mukherjee YouTube channel. First, let us understand what is electrochemical series, and then we will going to understand what are the different applications of this electrochemical series. Electrode potential is very important, because from this we can able to extract different types of informations. Electrochemical series is basically the arrangement of the electrode potential of a selected half cell reduction reactions in the increasing order. And if we see the series, that is basically represented as a table. In the table, that you will find that it has been written like this. The one reaction is given. The reaction that you will find that the oxidation state of the species, this is the oxidation state, plus number of electron. In the left hand side you will find, the right hand side that you will find the reduced state. And there in the extreme left you will have electrode potential in terms of volt. So reaction is basically, reaction we are given, that is the oxidation state plus number of electrons, that depends on which type of reaction is there. Then reduced state, and here the right hand side, extreme right hand side, that you can see the electrode potential that it has been represented in the volt, and it is the standard electrode potential. This is the standard. So what we observe, that at the top of the table it is been placed the furin. The furin gas, this is the oxidation state of this species, plus 2 electron, and it will produce its reduction state. This is the reaction, and from this reaction, this reaction have some electrode potential, and this potential is 2.87 volt, and that is plus. and this is the reduction potential. That we know two types of potential arise in the galvanic cell. One in the left hand side with anode, that is the oxidation potential, and in the right hand side it is the cathode where the reduction potential is there. But for the sake of the clarity, for the sake of make it easy, both the potential has been converted, represented as the reaction potential. So fluorine as the top of the table, it is having the highest reduction potential, electrode potential, and it is 2.87 volt. This means that chlorine has the maximum tendency to be reduced. That means chlorine is the highest oxidizing power, and it has been transformed in the fluoride ion, which has the lowest reducing power. So fluorine has the highest oxidizing power because its electrode potential is the maximum. And at the bottom of the table you will find that is the lithium. You can write this. This is lithium, and this is oxidation state of the lithium is lithium plus reduced, and it will produce the lithium solid. And its electron potential that we can see that it is volt. So lithium you can see has the lowest reduction potential, means lithium ion has the least tendency to be reduced. That is, we will call it has the lowest oxidizing power. At the same time, that lithium metal has the highest reducing power because its electrode potential is lowest. So from this we can able to understand the species which is having the highest reduction potential, it will have the highest oxidizing power, and the element which have the lowest, it will be the lowest oxidizing power, but at the same time it will have the highest reducing power. And in the middle of the C that you will find that is hydrogen. Hydrogen has the electrode potential, that is hydrogen gas, it has electron potential is 0. Above hydrogen, the species will have the higher tendency to be reduced. Below hydrogen, the species will have the lower tendency of the reduction. So you can see in the left hand side and the right hand side there is a different type of tendency. You can see in the left hand side what we will find, this is the oxidation state of the species. Here you can see the as we go from the top to the bottom of this series, what we find, the oxidizing power of the element goes on decreasing. Oxidizing power, you can write the oxidizing power decreases, and at the bottom, at the right hand side of this table, what we will find, the reducing power increases. So two things that we observe. In the left hand side we can see oxidation power as we decreases as we go from the top to the bottom of the series, and this. In between you can see there is a different elements will be there, and this element will the basis of their behavior, electropotential will be as we have understood. That is the reducing power of the element at the bottom of the table, and the oxidizing power will be at the top of the table of the element. And this is a very important thing to understand. You can also go for this table that is in between. There is several element you can see. Suppose this Au3, that is gold, it has reduction potential. This is a table that this is a very limited element, limited species I have taken to understand this electrochemical series. You will find in your book that is a lot more elements will be there. So what is there? The main thing that oxidizing power and the reducing power of the species can easily be assessed from this electrochemical series, and you can able to plan understand from this electrochemical series that when we go from the top to bottom, that is reducing power goes on increasing, reducing power goes on increasing, power goes on increasing, and when we go from in the right hand side and the left hand side, it is the oxidation power goes on decreasing. So at the bottom below hydrogen, every element has the tendency to reduce the top of the element. So we can say this will be easily oxidized by the elements on the upper side. So when we are going to plan the galvanic cell, that we have to always consider in mind its position of the elements in the electrochemical series. So now we have discussed what are the basic applications of this electrochemical series. Going to understand the application of this electrochemical series. There is various application that we can easily understand. That number one, that is that to predict the relative oxidizing and reducing power. To predict the relative oxidizing and reducing power, that we have already observed, already understand from the electrochemical series, that we can by looking on the position of the relative positions of the elements, that we can able to say relatively its oxidizing and reducing power. So you can easily understand from this, higher the reduction potential, higher the electrode potential, that is the reduction potential, higher the reduction potential means greater is oxidizing power, greater is oxidizing power, and lower is reduction potential means greater is reducing power. So we can say the fluorine at the highest oxidizing power, followed by chlorine, followed by bromine, and followed by iodine in the halogen group. That you can see the fluorine have the highest reducing potential, electrode potential, whereas the chlorine is followed by fluorine and then bromine and iodine. So we can see this. That is a very important thing. And same way we can see the reducing power of the element, that is lithium as the highest reducing power. Then it will be have the calcium, then this will have next potassium, then calcium, then sodium, and then magnesium. In this way it will be goes. So main thing that we have to remember the position of the hydrogen. Hydrogen have the electron potential is 0. The element above the hydrogen will have the higher oxidation power, and elements below the hydrogen will be the higher reducing power. So from the electrochemical series, this is very important thing that we could able to predict. Second thing, we can able to predict the metal replace hydrogen gas from acid. This is again a very important thing that we can able to understand from this electrochemical series. The metal, whether the metal react with the acid or not, and in that reaction whether it will going to replace the hydrogen gas. In this case, what is happened? If the reduction potential is lower, if the reduction potential of the metal is lower than hydrogen, then it will react with the acid and it will going to liberate hydrogen gas. Then we are able to liberate the hydrogen gas. That you can see, copper cannot displace the hydrogen from the acid, whereas zinc is easily able to liberate the, to be able to react with the acid and liberate the hydrogen gas. So from this we can able to predict whether the metal will displace H2 from the acid or not. Third thing, that is to calculate the EMF, electromotive force, from this electrode potential that we have in detail we have discussed in the previous lecture, that we have to take the oxidation potential plus reduction potential, and as it is a convention that IUPAC says that all the potential will be been expressed in the reduction potential. That is why we will find that is the EMF is basically E cathode minus E anode. So we can able to understand this, and this is the electrochemical cell. You can able to understand the what will be the standard potential of the cell. From this we can able to understand. So 3 things that we can able to understand from these things. Okay. Fourth number thing, that is again a very important thing, to predict the relative activity of metals. This says if the metal have the lower electrode potential, means lower reduction potential, it will be higher activity. It can able to replace the other metal which have the higher reduction potential, means lower oxidation potential. So you can say this metal will be active metal which will have the lower reduction potential. So lower reduction potential means that will be the higher activity of the metals, and we can arrange the activity in the decreasing order in this way. That is, you can see potassium have the higher activity than barium. Barium has the higher activity than calcium, then sodium, then magnesium, then aluminum. In this way, you can able to understand its activity. And from the electrochemical series, at the bottom of this table, you will find the elements, the metals will be the higher, activity is higher. So what is going to happen? It will replace the less active metal from their solution, because this metal is much more active. So this is the fourth point, that to predict the relative activity of the metal. That is to understand, to predict the spontaneity of the reaction. NEET redox reaction. If the EMF is positive, if the EMF is positive, then we say the reaction is spontaneous. Reaction is spontaneous. 6 point to determine the standard gives standards free energy change. Standard free energy change. From this electrode potential, standard electrode potential, we can able to understand the gives free energy from this formula, that is del G is equal to NF into E, where N is the number of electron that has been transformed in the redox reaction, number of electron transformed, number of electron transfer. F is 1 Faraday. 1 Faraday means 96487 Coulomb per mole. And E is the standard cell potential. Standard cell potential. So from this we will able to understand this del G, that is the standard free energy change, that is standard free energy change that we can able to assess from this electrode, from this standard cell potential, that what will be the standard free energy change. And from this also, 7th point, that is a very important, that equilibrium constant, we can able to understand, we can able to predict the equilibrium constant, that is Kc. So there is a 7 applications that we can understand. First application, that we can predict the relative power of the oxidizing agent and the reducing agent. Number 2, that we can able to predict whether the metal can react with the acid or not to produce the H2 gas. We can able to predict the EMF, we can able to calculate from the EMF of the cells. 4th one, we can able to understand the relative power of the metals, different type of metals, whether this metal will replace the metal, other metal from its solution. That we can able to understand from this electrochemical series that we have understood. We have also taken the examples, the which metal with the higher activity, the metal will have the lesser electrode potential, means reduction potential, with the lesser, with the higher activity as compared to the other. And then spontaneity of the reaction, we can able to calculate. If the EMF of the cell is higher than mean positive, then we can say that it is spontaneous. And standard free energy change gives free energy change, that we can also able to calculate from this. And also that we also able to calculate the equilibrium constant. So all these things can be easily assessed from this. So that is all for today's lecture, and this is, I think, that you can able to understand all the things, that how that electrochemical series, that is the electrode potential of the different half reactions, half reactions, is going to help us in different aspect. That is all for today's lecture. Thank you very much for watching. The next lecture we will discuss different aspects of this chapter. Thank you.